Still looking at the moon here. Everybody likes the moon.
So that's all of the 70s. Oh, it's just no.
Most people think we're all either Pennsylvania never went. Others say, well, we've been there, so we want to go back again.
Right.
So, money is billions of dollars. Now, what's going to happen over the next decade or so? China will, and they've got a mission going in the early 20s. So, I think we'll have another renewable taxes when we come in the mid to next one. Now it's now that we're getting commercialized, it's now we have companies that are sitting, for example, getting Americans to the International Space Station. Right now, we're taking a rocket from the Russians to get third party. So in other words, they're building the rocket. So it's going to have somebody else's rocket. And I expect the same evolution is going to do it for us. SpaceX, for example, they're supposed to be putting actually sending people into low orbits within the next decade.
So are you interested in the study of astronomy?
Okay, I don't want to go to Jupiter. I can't stand it anymore. I know there's a comet nearby. It's got one. Okay, here's Jupiter.
That is beautiful.
You said you saw 3 moons? Yes. One, 2, 3. I'm seeing, there's one here. Is this
I don't know who that is, but there's 23 that I see.
2 and 3. Okay.
I'm still going to attend next year's right.
So what detail we can get on the clouds here. Well, that's nice. By pulling the sliders, I can get moons out.
Well, Jupiter looks beautiful.
Whenever there's something special going on hook up like in Sacramento speakers here. They have some pretty cool speakers come in like last year. Maybe you've seen on television how the universe works. He's trying to take that theory.
I'm going to see if I can focus that any better, but it's pretty close.
That's what about a month ago. I went to Berkeley and watched Alex Orlando to speak. It's a part of it's just I try to keep my eyes open to bring in stuff. Things
about $3,500. That's probably like $2,500. It's a very special.
This is to be honest.
That's what we're there.
Myself included.
Which is what keeps tracking of.
We've been doing this for
actually, this scope is actually more
5
valuable
and
this
10 years.
because of the optics.
Really
This is
understand
the
just
mirror.
observation of stuff in the solar system.
That's one mirror.
And things like not tonight. Are a lot more time.
Yeah, it's been like lifelong passion.
So I've been really hoping to pour much longer conversation.
I won't. I know what I got my hands up. There was no lines. This is free game.
Yep.
Observatory and there's one Chico that's like this.
But yeah, I'm probably
When
go
Chico
off
misses,
Bring it down to
it's pretty special. People here are pretty special.
right in there. You better do it right.
Yeah.
Yeah, take I'm gonna move this.
If you want to bring it down, I'll take off the piece.
One last look at Jupiter and then
I've got two big telescopes here.
you see the moon?
I'm Toby.
Yeah, no, that's the Jupiter right there. And a moon, Okay.
Looks better from this.
Oh, sure. Ready? Move that scope. Scope for me.
You might want to think about Saturn.
This is so good.
I'm taking this cover with the moon, it's so bright, they cover up most of the scope.
That's awesome.
The cover's so sensitive that I can't take a picture of the moon without blocking most of the light.
Oh, now we're going to use all this.
How hard is it?
The camera. On that scope, there's a mirror sitting right here. And it's pulled off that mirror, put a camera, and there's a 14-inch mirror all over the bottom of this.
Okay, we're gonna go for a comet next.
What's a galaxy?
Huh? Comet and then galaxy, because we get stuck on the
Because
galaxy.
right there, M51's right in the head.
If we go to the galaxy first, we get stuck there. The comet, we can look at it and say, okay, yeah, we saw it.
So from now on, you want to look at the screen because in the eyepiece you can look through it, but you won't see anything.
Yeah, the comet's kept back, you might see this little fuzzy ball.
Maybe.
It's a comet, P22. IKEA?
IKEA.
IKEA. Oh, wow.
You know, comets is a big, dirty ice ball that's orbiting around the sun. And meteors, what you see is debris that may have come from a comet that enters the Earth's atmosphere. And most of the time it will burn up. On occasion, you'll get the meteor turned into a meteorite. What you want to deal has is that big.
Uh-oh, we gotta focus.
I don't see anything in eyepiece, but I don't expect it.
I'm gonna need to focus this up first.
And you probably heard of you've probably heard of
And
these
it's probably
very
not your shallow.
what those are caused by, we know that they happen because the Earth's orbit is very predictable, and where I have gone through centuries in the past, if the Earth goes through that debris trail, so it's going to leave a lot of dust particles. Some are very, very small, and the grain of sand. Some are slightly larger. So the Earth travels through that residue that went decades or centuries ago. You'll get all those particles that are atmosphere. That's where you get the very cool.
So what I'm doing is focusing the telescope right now.
That's how,
I think that's
that's why we know night.
What is that? That's a star. Let's just get it as small as I could so that we can focus up.
Now, we don't know.
Now I'm going to see if I can find the comments.
They don't know until, well, or the day after.
Which telescope is this, the 14-inch?
Yes.
Or to get. So, it's a matter of how wide that debris.
So there's a place to look for
Yeah, it should be. See, this is where the scope is pointed right now. But the problem is, the comet's so big, we might be just looking. This glow might be. So it might be so big that we're not looking in the scope. So let's go to. What did you want to see? You have any advice? You have any advice? What do you want to see?
Well, that one actually blew up before it hit the ground.
A nebula. What kind of nebula?
Wiped out miles.
We've got lots of galaxies in this area. Oh, there's a planetary nebula. That's that. Supernova? We did have one star here. I got to look at the lunar imaging one a few months ago. That's probably showing it away by now. But let's get it on something like
something like a galaxy or a nebula.
yeah, here we go. The needle galaxy is kind of cool. Scope moving.
And blew up in the atmosphere. But that wave it made when it blew up, it bucked it all.
What is it called?
This is called the needle. Needle.
This is an interesting tool. What is it? Well, I mean, you're able to use your tablet to find whatever.
Yeah, so it shows me where so we should have this galaxy right here.
There's no clue.
Oh, he's moving around.
Yes, I'm just a spectator here.
Oh my goodness.
It's got a double.
The Needle Nebula.
The needle galaxy.
It's possible to look things up on his tablet and then have the scope turned to that spot.
There's actually another galaxy right there. So, this is just another galaxy that's.
You don't see these with the naked eye, with the other scopes. In fact, you wouldn't even see it with the 17-inch scope with your eyes, because you need to have the time exposure. He's taking 8-second exposures and actually stacking.
If you saw that on the 17-inch scope, it might look like that. You see that center core, but see, if I can, with the camera, I can adjust the sensitivity and do all kinds of things to make it so that we can optimize it so we can see it really nice.
What a great tool.
So you never see it through the telescope?
No, you wouldn't see this with your eyes. The camera is much more sensitive. So that's what this camera is.
The camera's looking through the telescope, but it's the sensitivity of the camera looking through the telescope that allows you to do the exposure change.
Right.
So the camera combined with the telescope is doing that.
This image here, 10 years ago, was taken in an hour to produce. This one is happening in 90 seconds. Because it'll take a picture, and then 9 seconds later, it'll take the next picture.
Huh.
Okay. My daughter's downstairs. They got him. He's a husky. I mean, just, they remove the beat of him.
Meanwhile, back on Earth.
Yeah, so you give her a thumbs up.
So how far away is
This is Galaxy. So we have all kinds of information about the galaxy right here. So that's what it should look like, pretty much. And we can find out how far away it is. Let's see. It's 13 million parsecs, which is 42 million light years away. So that's a long ways away.
So you can see so you're able to, so in a matter of a couple of minutes, you're able to bring up a galaxy that's 42 million light years from here.
Exactly.
On a 14-inch telescope plus a camera. That's pretty darn good.
So these images that we're making today are better than some of the best telescopes could make in the 60s. So it's just amazing. So that is a spiral galaxy edge on. Okay? If you want to see a spiral galaxy more face on, we can do that too. Okay.
Well, that's the one they were showing out there earlier.
Yes.
You can.
So what we do with these cameras, we can go into what we call microscope mode, which makes it really sensitive. So you'll see that it's just here really blurry. But when we go to this thing, let's see, you'll see the scope moving through the sky. Let's zoom out. So these streaks are stars as we're going by.
Hey, Charlie.
Yes.
Watch your counterweight, will you?
We're supposed to telescope moving.
Yeah. I've been cold cockfighting twice in my career out there.
You're doing M31, M51 again? Oh, they were showing that
I was actually
earlier
replaying data
from
from
another
before.
night.
Yeah. So if you look at this, this is showing us exactly where the scope is pointing right now. And it's exactly for this wonderful galaxy. And there it is. So we do this first so I can, if I needed to adjust it, I can move it left and right and up and down to get it right in the middle.
Telescope and bend in my shoulder.
There you go. And then we'll go back to color mode.
Can I have it, Charlie?
It sounds like a chicken or an egg thing. Was
So-
he born with a telescope in his
So
shoulder?
here's a 9 I think Forrest was. There's a 9-second exposure right there.
And that's the way it looks right now.
Now, see all these little,
Yeah.
these
Oh,
little
there you go.
marky
Just
things?
came back.
That's because Forrest is over there messing with the telescope.
Yeah, blame it on me. Oh, yeah, blame it
He's
on
got
me.
his shoulder in it or something. I don't
Yeah,
know.
right.
We have 4 galaxies over that picture? Over there?
So
Oh, it's a double image.
let's just reset this.
I know it's a double image. You know immediately.
He moved it while I was there. So if we look at there, there's the whole frame. But yeah, look into here, and then we're gonna have, because you notice it just got a little bit better.
Yeah.
So every time this says 9 seconds up here, we're doing 9-second images. You'll put another picture on top of it and average it out. So it's averaging out the noise.
What's the other one looking at?
So as we go,
What do you mean by the
What's the other
noise?
one?
What do you mean by averaging out the noise?
so it's actually stacking these pictures digitally.
Yeah.
And if you think about noise in a picture is random. It's caused by the chip and everything else. So if you have random things going up and down, well, what's not changing is real. So if you take the average of 10 or 15 pictures that have random noise in them, that random noise starts to get less and less and less. And this starts looking smoother and smoother. And now I can actually take this and say, well, the middle of that is too overexposed. So I want to get it down here where it's not overexposed. And then I want to get the mid-range colors up here. And then I want to take the darks and make them darker.
Wow.
And now we're seeing a lot of detail here. If you look at here, you can actually see some of these star forming regions, and you can really see the spiral structure. It's a little blurry when you zoom in that far. But the other cool thing is, see this, there's the halo out here, and this is actually another galaxy right here. So there's like an elliptical galaxy here, and you can see this dark area here. That's an arm from this galaxy. Now they are touching. It's kind of like my hand of my fist is like touching if you look at it the other way, right? But it kind of looks like you're touching like that. So this galaxy is actually behind the other galaxy. And what's happened is that this galaxy came cruising past the first galaxy and finally it started dragging those arms out and it actually went behind it and it's looking like this. So it's, and back through again, eventually you should get a version of one big galaxy. They're colliding, is what's happening. And that's going to happen with us and Andromeda in about 5 billion years. So Andromeda flies in cars. Now what happens if one galaxy goes through another galaxy? Everything gets further through it? No? How many stars do you think would actually smash into each other?
Probably
Not that many. Yeah, there's a lot of perturbations that happen. But this all that fog is individual stars. That's all stars.
There's a lot of space in between those colliding galaxies. Lots of spaces.
Exactly. People don't realize that between us and the nearest star is 4 light or 4.2 light years, right? You're 6 trillion miles. Okay, so a million miles on a star and a million miles on a star with 6 trillion miles between them.
There's a lot of space.
There's not much chance that they're going to hit anymore. So these will go through each other just like whoosh. And you're right, tidally, all of a sudden, that's what's happened here. This might have been just a big ball, but when this came through here, it sort of dragged that out there so that this arm comes out here. So that makes spirals even more pronounced with different shapes. We can see other galaxies that have done that. I'll show you a galaxy nearby. Let's see, we go to M82. Let's just type it in. So what would...
So you're looking at another galaxy.
So another galaxy. It has had an interaction with another galaxy.
It's pretty expensive to buy all these, and they only do it to full subscribers. Like, you can't just go to one.
So with what you've already got, would you be the edge of having a larger scope?
Or maybe you have a friend that.
This is actually kind of a sweet spot. The problem with a larger scope is you get smaller field of view. If I look at this camera on that scope, we can't do the magic thing where we go up in the top. We don't have the special correcting lenses. That scope is designed to have cameras at the back end of it. And what happens is, if I look at this galaxy in that scope, it's about that big, but then there's a lot of other things, like the moon. We can only look at a couple craters at a time. So this galaxy looks very different, right?
Yeah.
And this is Spiral Galaxy's edge, but look how jagged it is in here. It has had another galaxy come through it. So, like I say, it's all. Now, see the pink stuff in there? When hydrogen gets compressed, it ignites and forms stars. So, by having another galaxy come through here, all the collisions cause more things to have more star forming regions. So,
It's almost 10:30.
I believe that's a gamma boss. This galaxy was the cause of this galaxy. The forest? Was MEA2 perturbed by MEA1? Okay. I just want to make sure before I say there's another nearby galaxy that went through it. And I can show you that one too. So I just MEA2. Now this is how the telescope moves when it does this.
It's not a TurboTax commercial.
Okay. It just had a.
That was it?
That was it. So this next 8 seconds you're going to see.
That's a huge star.
You can see it. You can see the pink area.
Yeah. That's all these star formations.
Caused by. Oops, did it not go? Scope moving. There.
No.
Okay, so I could almost get these two in the same frame. Maybe I could try to, but
Yeah, you can't with 17.
that's because it moved.
Oh, there it is.
So this is the other galaxy. And this galaxy's kind of see it's this way around. Because the scope is still moving a little bit.
So every 9 seconds it gets a little more clear.
Yes.
And you can change that down and get a conversation.
How many seconds it was? What does it look like? What? Because the scope was actually moving during the exposure.
There's a lot of ways.
So,
um,
that could be. That most likely is a binary star system. And then you'd also see a lot of different colors in stars. See how some are red and some are bluish. Those are the color temperatures of the stars.
And that's what we try to do. And the school has its own responsibility, and there's
Yes, quasars. They're way out there. You know about quasars?
No, we look for all of them.
I think there's one in like August or something like that. There's one of other galaxies that see those.
They're not really sure about quasars yet.
Yeah.
Are they? They kind of blink off and on, or they appear to at least, right?
So we just happened to be on the college's land. So they were.
Hey, Flores? We got some questions about quasars I can't answer. Quasars. Besides the TV. You'd like to know what we know about them.
And what they think is when you look back at these are probably some of the black holes that began with
So we're not part of the college, we just use the
and
college
they're
property.
putting out proof
We do get college students up here that are taking like astronomy.
black hole tons of produce energy. That's the right?
It produces energy because it's so gravitationally
They'll come up
solid
here
that
with
things
the
you think
assignment.
about it,
They ask me questions and
What happens?
and that's the nature of astronomy class. So I wouldn't, that's not,
rotating so fast that material
that's
actually
neither,
stands up and gets to the polar regions of
that's neither
black hole.
interested in or nerds. It's just what it is. They just know more than someone who's just trying to learn.
If it spews out of space and we happen to be, right in the place, it's incredibly energetic.
Reading and studying and thinking about this stuff for decades. Not just something.
Yeah, trying to learn the first, 50 facts about it. So yeah, all of this. I've thought about it too. There's probably not very
Black holes and
it'll happen.
but the actual star formation and the accretion of itself is what putting it
Is this something else?
Yep.
Oh, what was that?
So this is the owl nebula.
Oh, the Owl Nebula.
So this is a dying star with a little white dwarf in the middle.
It's really amazing what that kind of stuff looks like from Hubble.
So you can see the two dark areas there.
Yeah.
White bottom. So there's a white dwarf. What's that? Let's see what's up yet.
Because I had already spoken to the top.
Oh, you think it might be too early in the night?
Yeah.
Oh, that's right. So, that was pretty neat.
Is that M27?
That's been a lot of it.
I think it's
I'll send along because he's already
No, it's
a
okay.
few years ago.
I see it all the time, but
In our knowledge.
let's take a look and see where it's
I
at.
tried to keep up for a few months and that was about it.
You see this spot here? I zoom out. That's the wall. See the cat over there?
Oh, it's
That's,
down there.
that's where it would be.
So,
I was afraid to see that.
all right.
Oh, but the Hercules cluster is gorgeous.
Mr. Brand.
What is that, Charlie?
Is it,
Owl.
So it's a cat nebula.
So what are you looking at now? You're going to?
So we go to the Hercules cluster. Hercules cluster. This is a globular cluster. What's that? This is near the Hercules shoulder, basically.
that's a pretty good one.
Hercules has like a keystone shape.
Whoa.
So
This
it's
is
called
the Great Hercules Cluster. It's a globular cluster in M13. Let's bring this down here so we can see the stars in there. Approximately 500,000.
500,000 stars.
Yep. All gravitationally bound to each other. So if you were a planet somewhere in there, if there were planets in there, it'd never be nighttime. So, but this is really pretty to look at in the big sculpture. So, yeah, I call it diamond brooch. It's like a top 8 diamonds or something like that. But you can also see kind of blue stars and yellow stars in there too.
Yeah.
And those are some of the oldest stars in our galaxy. It's actually on the fringe of our galaxy. You see, it actually kind of extends out to here. So it's just really a pretty structure.
It's very cool that this camera stacks images and keeps getting clearer.
Yes. Yeah. I mean, as you stand here, it just gets better. So, usually we had a video camera, which did, it kind of integrated more pictures, but this one really does do some nice processing.
If you type in cockpit, he'll be the only one that comes up.
Anyway, I guess that's the end of the tonight.
Thank you, that was pretty nice.
Something like, so the universe.
This type of stuff a lot.
Okay.
It's pretty good. Adrian got some special requests there and some other stuff.
So yeah, if you're really interested in certain things, if you can look up on the internet, see if they're out there, right? If they're visible from here, then definitely that's the best way to look up on the internet. Just about anything in there. Are you saying the galaxies tend to spring out into springs and clusters, and they're kind of traveling in groups. Yeah, I don't know anything. I just, showing some cool stuff. We're not necessarily really professors, although of course it's not a lot of astronomy. He actually likes the script of observatory.
So they're still able to do things in perfect. That's LA, right?
Well, it's a little disappointing because their scope, they've got a really nice 20-inch refractor made back in the 30s or something like that. But these put it to shame visually. When you look through it, it's like, okay, yeah, that 4-inch is almost as good as
Because
a
of
job.
the
But it's kind of
light
cool.
pollution
It's just
and
cool. Well, it's not. This 4-inch telescope, you look for the moon at it, you don't see any of the color fringing like you see in a lot of scopes. That thing is, 60 years old, and it's not that. This has a apochromatic lens on where there's 3 or 4 lenses all together to get rid of any of that chromatic aberration. So really, we have the higher technology stuff. They have a cool facility that's it's really a historic.
Well, it's a historic site.
And so when you go there, you're gonna line that's 3 hours long, and next, almost like what we're doing here. We don't normally like to do, just look at one thing all night long. This is the kind of stuff interact and talk to you about things and show you more and more stuff. It's just getting better and better. We're standing here. So, and when I see that out
Yeah, but other.
That's fun.
Yeah, it's out there too. That looks really cool out there.
That's a great one. I love doing this.
Very good.
It's awesome.
Yeah, he's got that out there, and it looks even better out there right now. We ought to go, buddy. It's 10:30. Yeah, well, I was waiting for this. I was thinking of trips that have gone on backpacking or in the high country, it's clear.
We've done that.
10 or 12, 15,000.
When we go camping up the mountains in the summertime, I woken him up at about midnight, and we can see the Orion range of the Milky Way. It's clear as you can see it, and it's incredible. It's just,
Yeah, no light pollution and it's some miles.
Adrian, come on, you wanted us to go look at this on the big screen.
Then we gotta go, right?
that's the one.
So I was just coming up from Mars, it gets a little higher than the horizon, we'll be able to see that in the telescope, because Mars is close and it's gonna be a long time. So, thanks for coming out.
A busy day. Cindy said at least 400.
Yeah, I mean, that's gonna be more than that.
Yeah. It's crazy. See it on the sky.
Put these away, Jackson.
Okay, so we're gonna shut down the broadcast now that everybody's pretty much out of here. And that was M13, our last image of the evening. So, thanks for joining us. Hope you enjoyed it. Let's see. And we'll put this up here for a second. So, I'm Charlie Philbin, Chief Docent, wishing you a very good night. Thank you.